Okay, so this is the fifth session of our detailed logic design lab, and in this session we would be looking for designing of a gray to binary code converter. In the last session we have seen or we have designed a binary to gray code converter, but here we will be designing gray to binary code converter. So the process, theoretical process as per is somewhat similar to that of our binary to gray code converter, but with a slight difference. Okay. So the similarity is that in both the processes we use XOR gate. Okay. But here instead of XORing binary to binary, we just XOR the binary to gray code. Okay. So for example, if we have a gray code given as G3, G2, G1, and G0, and we have to convert this to binary code. So what we will do, we will just take first bit as it is, that is G3 will become B3, where we represent the binary code digit. Okay, then for B2 we will perform a XOR between B3 and G2. Okay, perform XOR between B3 and G2. So B2 will be equal to B3 XOR G2, whereas in previous exercise what we were doing, we were just XORing the binary digits on same level, but here we are just XORing in the cross digits. Similarly here we will do the XOR operation, so we will get B1 as B2 XOR G1, and from this XOR operation we will get B0 as B1 XOR G0. So we look for designing the logic circuit. It will be something like this. From G3 direct we will get B3. Okay, then for B2 what will you have to do? We have to do an XOR operation between G2 and this B3. Okay, this will give B2. Then again like this, B1 we will get from XOR of B2 and XOR of G1. Then from next XOR, for getting B0 we will have to do XOR of B1 and G0. Okay, so let's design this on Logisim. Let me exit this screen. Okay, so here we have the main drawing panel of the Logisim. What we have to do, we have to take again 4 LEDs and 4 inputs. So just I'm copying from the last circuit. Open, this was our binary to gray code converter. I will just copy it and will rewire it. Let me, I will just place it. So these will be our 4 pins. Okay, so these will be our 4 pins of the representing for the gray code. So let me rename these G3. This will be your G2. This will be your G1, and then this will be your G0. And we will need corresponding LEDs, 4 LEDs for representing the converted binary output. So we have placed the LEDs. Now let us pick those XOR gates. So we'll just go to gates, we'll pick XOR, place it like this. First we'll make it a 2 terminal device, 2 input terminal. Okay. Now we will connect this. G3 will directly go to your B3. Okay, so this connection done. The next connection will be from this pin and between this one. Okay, then again I will just select it, copy it and paste. This copy and pasting I'm doing because otherwise if I just take fresh XOR gate from here, then it will again have 5 ports and again I will have to do this editing. So to avoid this, I'm just copying it and pasting it. So this wire I will take from here and connect like this. This I will connect to this point. This will be my output. And then my third XOR gate, place it like this. Okay. So now once the connection is made, connections are made. Now let us arrange these so that the circuit should be more recognizable and more readable than as it is now. And I think I have already explained to you why this arranging is much necessary and should be done properly, because if you are making some bigger circuits, it will be difficult for you to recognize or understand this wiring later. So it is better that we make a habit of doing this initially from the start. Okay, so this is over. Let me give nomenclature to these LEDs also. So this will be my B3, this will be my B2, this is B1, and then finally this is your B0. Okay, let us see if it's working or not. Okay, so we can see all the wires are working properly, and from the truth table or just from taking an example, you can verify the validity of these circuits. Okay, so let us take an example to verify our circuit. For example, we have a gray code that is given by 1010, and we have to calculate its convert it to its binary equivalent. Okay, so this one will come straight, then 1 and 0 XOR will be equals to 1, then this will be equals to 0, and then this will be equals to 0. Okay, so let us see if this works out. So we have 1 0 1 0, and the output is 1 1 0 0, and we can see that this matches our actual theoretical or mathematical calculations. Okay, so this circuit is functioning properly. Okay, So again, let me mark it. Writing I'm doing every time so that you people can make a habit of marking each and every experiment that you perform with your name. Okay, so let me export this also. Export image, uncheck this, JPG. Okay, and this was my gray to binary code converter. Okay, so in next session we will see about our multiplexer. Okay, 2:1 multiplexer or and 4:1 multiplexer we will see in our next session. Okay, till then all you people are advised to read on the theory of multiplexers, although we will briefly discuss that also in our lab session, but it is recommended that you study on your own prior to coming to these sessions. Okay.